Good evening, children.
Good evening, ma'am.
Good evening.
Good evening,
Good
ma'am.
evening, children. Good evening. So, children, before we start off today's session, I need to give some clarity upon the proceedings of the class. So, the students who have been attending the class right from the first day, that is from the day of commencement, uh, you all know that we started with the chapter statistics, correct? Yes or no?
Yes, ma'am.
Yeah, we have completed statistics in full. We did not do ogives because we wanted to just check if that's a part of the syllabus this year or not. And it is not. The deletions, which had been made for the last 2 days continue this year also. Continue this year also. So we have finished, in that sense, we have finished statistics in full. We did not do ogives, and that is also not a part of your syllabus this year. So statistics is done in full. Agree, all of you? I told you that only ogives is remaining to be done, and now we don't have to do it. Agree, all of you?
Yes.
Okay.
Yes, ma'am.
And then I started the second chapter. I started was real numbers. Real numbers. So when we were doing real numbers, uh, some of you told me that again that's when it was formally announced in your schools that see, like we started off the classes in February. Okay, so it was when I was doing real numbers that some of you mentioned in the class that the deletions which had been for the last 2 years continue this year also. So when I was doing some part of real numbers, when I was doing some part of real numbers, some of you told me that certain portions are not there. So I thought, okay, fine, let me not proceed with this chapter real numbers. Let me just check about the deletions and then complete it. So considering the deletions, I have to only complete, about 10% of real numbers. We start with real numbers. We start with real numbers, not abruptly. Intentionally, we start with real numbers. Okay, intentionally we start with real numbers because I had to check like what part of real numbers are there and what is deleted. So now after having a look at that 10% of real numbers, that is some portion of FTA I have to complete. Some portion of FTA. See, if you look into NCRT, I've completed everything. But then you know that we study a little beyond NCRT, but in your whatever is in your syllabus, needed for your syllabus. So in that sense, a little portion of real numbers has to be completed. We'll do that. We'll do that. Okay, we'll do that. So now, since I could not continue with real numbers because I had to make sure what portion is deleted, I started with linear equations just to continue the class. Linear equations was not the next chapter in my mind. I wanted to do polynomials. I wanted to do polynomials. I wanted to do polynomials, but since my presentation was not ready that day, my PowerPoint presentation was not ready that day because suddenly, I had to do. So since, like linear equations, I think I had something of linear equations. So that's why I started linear equations for you. And I did the word problem. I did not give you the introduction to linear equations. I did not give you the introduction to linear equations. I just started off with the word problems because that does not need an introduction. You have already seen two equations and solving two equations in the last year. Sorry, during your 9th standard in the chapter polynomials. In the chapter polynomials, you have come across two equations where you solve the two equations and find the values of a and b or x and y, whatever. So in order to continue, I just started off with linear equations, but polynomials was the next chapter in my mind. But my PowerPoint presentation was not ready as on that date. So I started with, because I had to continue with the class, so I started with linear equations. And I've done some part of word problems now. Class, are you all listening? Am I clear so far?
Yes, ma'am.
Okay.
Ma'am.
Now
Yes,
listen to
ma'am.
me carefully. Since polynomials is the next chapter, now I'm going to. So now linear equations, you've learned some amount of word problems. Word problems, you have understood some amount of it. I've already shared the pictures also. Pictures, I had already explained. Linear equations, whatever I shared with you, the word problems, I had already explained them in the class. And I sent the pictures to you. I told you make a booklet and, practice it yourself. Yes or no, children?
Yes, ma'am.
Yeah. So statistics is completed in full. Real numbers, little part of real numbers is to be finished. I'll finish it. Okay. Then I did not start. Linear equation was not the next chapter in my mind. Somebody's mic is enabled. Please disable your mic. Danya, disable your mic. Okay. So some part of, so I told you, so since I could not continue with linear equations, I just started real numbers. I just started with linear equations in order to continue the class. Now, we will do linear equations later. I have to the next chapter in my mind was polynomials. Now, when I start polynomials, I'll finish it in full. Because I don't want children to have an impression that this lady starts every chapter and leaves everything half the way. No, no. That was because we were not sure about the deletions. We were not sure about the deletions at that point. So now that it's confirmed that, the deletions for the last 2 years continue now. Now I know like what is there and what is not there. So here afterwards, whatever is started will be completed in full. Please get that because I don't want any miscommunications between the students and the parents. Obviously, any chapter started will be completed in full. Nobody will start a chapter, leave that half the way, start another chapter, leave that half away. So I have some genuine reasons for doing so. Now I'm going to start the chapter polynomials and we will finish it in full and then proceed to the next chapter. And the next chapter may be linear equations. Okay, I'll let you know about that. Or maybe I have to finish the rest of real numbers and get back to linear equations. Okay, having said that, let me begin with the next chapter, polynomials. Is that fine, children?
Yes.
All right. Fine. Yeah, please start writing. All right, stop writing and listen to me. Linear polynomial. An expression of the form ax plus b, like 3x plus 5. Okay, an expression of the form ax plus b. So like 3x plus 5, where a is 3 and b is 5. Okay, so you can also consider root 2x minus 3 by 2. You can also consider the polynomial root 2x minus 3 by 2. This is also an example of a linear polynomial. Okay, it's linear because the power of the variable x is 1. It is linear because the power of the variable x is 1. Now, this is of the form, this polynomial is of the form ax plus b, where a is root 2 and b is minus 3 by 2, where a and b are real numbers. But the coefficient of x, a, should not be 0. The coefficient of x, which is a, should not be 0. So an expression of the form ax plus b, where a and b are real numbers, but the coefficient of x, which is a, should not be 0, is not 0, is called a linear polynomial in one variable x. A and b can be any real value, meaning it can be rational or irrational. It can be rational or irrational. See now, it can be cube root of 5x minus something like 4th root of 10. This is a linear polynomial in one variable x. It is a linear polynomial in one variable x because the variable is x and its power is 1. So it's linear. So it is linear. The coefficient of x, which is a, is any real value. And b here is minus 4th root of 10. Can be any real value. So an expression of the form ax plus b, where a and b are real numbers, but a should not be equal to 0 because 0 is a real number. Okay, 0 is a real number, but a should not be 0. It's called a linear polynomial in one variable x. Now, when this linear polynomial ax plus b is equated to 0, it's called a linear equation in one variable x. When this linear polynomial ax plus b is equated to 0, it's called a linear equation in one variable x. So which means if you equate 3x plus 5 to 0, 3x plus 5 is equal to 0. 3x plus 5 is a linear polynomial. 3x plus 5 is equal to 0 is a linear equation in one variable x. Similarly, root 2x minus 3 by 2 is equal to 0. What I showed here, root 2x minus 3 by 2 is equal to 0. When you equate these linear polynomials to 0, it is called a linear equation in one variable x. That's what you see here. Now, when we say a linear polynomial, when we say linear polynomial, we use the term 0. When we say linear equation, we use the term root or solution. When we say linear polynomial, we use the term 0. When we say linear equation, we use the terms solution or roots. So see the last two lines. A linear polynomial has one and only one 0. When you say polynomial, you say one and only one 0. But when you say equation, a linear equation has one and only one root or solution. Both are the same. When you say polynomial, you say 1 0. When you say equation, you say one root or one solution. Now, why is that so? I'll give you time to write, children. Just listen to this. So because let's consider a simple equation. So 3x minus 5 is equal to 0. Okay, when you solve this, what do you get? X is equal to 5 by 3. X is equal to 5 by 3. Now 5 by 3 is the one and only solution. Is the one and only solution or root, because that's the only value which can satisfy this equation 3x minus 5 is equal to 0. Take up the left hand side, 3x minus 5. In place of x, use the value 5 by 3 minus 5. So 3 cancels, 5 minus 5, it is 0. The RHS is 0. We are trying to verify. We're trying to verify if 5 by 3 satisfies the equation. And yes, Now, any other value in place of x, 3x minus 5 is equal to 0. In place of x, other than 5 by 3, you use any other value, it will not satisfy the equation. That is, the LHS will not be equal to the RHS. See, in place of x, when you use 5 by 3, okay, so 3 gets cancelled, 5 minus 5 is 0. And 0 is the RHS also. So the equation is satisfied when x is equal to 5 by 3. For no other value of x, will the equation be satisfied. So you will get some value in the LHS. The RHS is 0, but in the LHS you will not get 0. Only when x is 5 by 3, you will get 0. If x is not 5 by 3, you will not get 0. That is why we say that a linear equation in one variable x has one and only one solution. Anything. I'm just taking simple examples. So 2x, say, plus 7 is equal to 0. Okay, so 2x is equal to minus 7, x is equal to minus 7 by 2. This is the only solution. This is the one and only solution of this linear equation, one variable x, because when you take the LHS 2x plus 7, and in place of x, when you use minus 7 by 2, minus 7 plus 7, 0. LHS is 0. RHS is also 0. So that means the value minus 7 by 2 satisfies the equation. Write down, children. Write down this. Let me know when you're done writing, children. Done writing, children?
Yes, ma'am.
Okay. Others can
Completed, ma'am.
Okay,
Completed, ma'am.
very good. All right, children. Now, quadratic polynomial. Quadratic polynomial. Okay, see, I deliberately did not tell you the meaning of the term polynomial because you already have learned it last year. Polynomial is a term which is very familiar to you. So purposely, intentionally, I did not define polynomial. I straight away started with linear polynomial and quadratic polynomial. You are going to identify. I'm going to give you some examples where you will be asked to identify if the expression is a polynomial or not. Be ready for that. Quadratic polynomial. Okay, an expression. Start writing with me. Finish writing, children, and let me know. I'll explain.
Completed now.
Okay. Done, all of you?
Yes, ma'am.
Yeah. So what is a quadratic polynomial? An expression of the form ax squared plus bx plus c, where a, b, and c are real numbers. But the coefficient of x squared, which is a, should not be 0, is called a quadratic polynomial in one variable x. It can be in one variable y also. This is just a standard form. You can also write a y squared plus b y plus c. Okay, so this is just a conventional way of writing. So you can use any variable x, y, z, any variable you can use. So this is a quadratic polynomial in one variable x. And a quadratic polynomial has at most 2 zeros. See, a linear polynomial has 1 0. A linear polynomial has 1 0. A quadratic polynomial need not have 2 zeros. It'll have at most 2 zeros. That means it can have a maximum of 2 zeros. Maximum of 2 zeros means it may not have a 0, or it can have 1 0 or a maximum of 2. So there are quadratic polynomials with no zeros. I'll show you examples. There are quadratic polynomials with no zeros. That means there is no value which can satisfy that. So there are quadratic polynomials, with no zeros. Some polynomials have only 1 0 and some others have 2 zeros. But a quadratic polynomial cannot have more than 2 zeros. A quadratic polynomial cannot have more than 2 zeros. It may not have zeros at all. It's a quadratic polynomial. It may not have zeros at all. Or it's a quadratic polynomial. It may have only 1 0, only 1 0. Or a different quadratic polynomial may have, I'm not saying one quadratic polynomial, different. A quadratic polynomial can have no zero, may not have any zero. Some other quadratic polynomial may have only 1 0, and some other may have 2 zeros, 2 zeros. Okay, so there cannot be a quadratic polynomial with more than 2 zeros. So we say a quadratic polynomial has at most 2 zeros, a maximum of 2 zeros. So this means it may have no zeros. It may have no zeros. That means it may not have a zero. Okay, it may not have a zero. Let me correct that. It may not. The meaning is the same. It may not have a zero. Okay, or it can have 1 0, or you don't change it. You don't change it. It's fine. It may have 1 0 or a maximum of 2 zeros. When a quadratic polynomial is equated to 0, it's called a quadratic equation. Therefore, ax squared plus bx plus c is equal to 0 is a quadratic equation in one variable x. A quadratic equation has at most 2 zeros. 2 roots or 2 solutions. I'm sure it's understood. So now check this. For example, 3x squared minus 4x plus 5. Okay, now this is a quadratic polynomial. It's a quadratic polynomial. Now see, this can be root 5. This can be like 4 by, like root 3. whatever. So this can be cube root of or some fourth root of. So A, B, C are real numbers. A, B, C are real numbers. See, it cannot be like this, like some seventh root of 3x inside. This is wrong. This one is not quadratic. There should be x squared. X square should stand out. The coefficient can be anything like this. The coefficient can be anything. This one should not extend like this. So x square stands alone. Its coefficient can be anything. X, its coefficient can be anything. Any real value. Now this one, any real value, rational or irrational. Now this is an example of a quadratic polynomial. Why quadratic? Because the power of x is 2. So quadratic. So quadratic. There's only one variable x here, and the highest power of x is 2. And so it's a quadratic polynomial. When you equate this quadratic polynomial to 0, it's called a quadratic equation. So you can see this is A. The coefficient of x square is A. The coefficient of x is B, and the constant is C. So when you compare ax square plus bx plus c is equal to 0 with this one, you get A is equal to 7th root of 3. Okay, B is equal to minus 4 by 5, and C is equal to root 7. Clear, children?
Yes, ma'am.
Yes.
All right. Now I'm going to give you an example of a quadratic equation which has no zeros. I'm going to give you an example of a quadratic equation which has no zeros. Consider this. Okay, very simple one. So x squared plus say 49 is equal to 0. Now this is quadratic. This is quadratic because it's x squared plus 0x plus 49 is equal to 0. Now don't say that that x term is missing. See, x square should be there. See, this also is a quadratic equation. X square is equal to 0 is also a quadratic equation. There should be x with the power 2. Then it is quadratic. That's all. The x term and the constant may be there, may not be there. Okay. So if it is x square, it is x square plus 0x plus 0 is equal to 0. So when you compare this with ax squared plus bx plus c is equal to 0, you have a is equal to 1 because this is 1. Okay. And b is 0 and c is also 0. Simply x square is also an example of a quadratic polynomial, or x square is equal to 0 is an example of a quadratic equation. For an equation to be quadratic, you just need x with the power 2, that's all. Or any variable to the power 2, y to the power 2, that is enough. The other terms, now if it is x square, the other terms, the x term and the constant, they are there, they are not there, that's okay. Sometimes only the x term is there, the constant is not there. Sometimes the constant is there, the x term is not there, that's okay. But you have this x term with the power 2, so it's quadratic. So in that sense, x squared plus 49, x squared plus 49 is equal to 0 is a quadratic equation in one variable x. The x term is not there. That means it is 0x plus 49 is equal to 0. The x term is not there, meaning 0x. Now we're going to, find out some values for x which will satisfy this equation. Now, since it's 45 here, let's take 7. If x is 7, okay, x is 7. So let's take the LHS. When x is 7, let's take the LHS. What's LHS? X squared plus 49. So now instead of x, we'll use 7. So 7 squared plus 49. So 49 plus 49, 98. No, but the RHS is 0. So it's not satisfying because LHS is 98, RHS is 0. It's not. So x is equal to 7 does not satisfy the equation. Okay, let's say x is minus 7. Okay, maybe this will work for us. X is minus 7. X is minus 7. So that means it's going to be minus 7. The LHS is going to be minus 7 the whole square plus 49. So minus 7 the whole square is what? Minus 7 into minus 7 plus 49. Plus 49 plus 49. Oh, again, we're getting 98. Now tell me, other than 7 and minus 7, if you try anything else, how will you get 0? You wanted to get 0. For 0, the closest thing you can try is plus 7 minus 7, because only that's going to give you 49. So maybe if you get minus 49 plus 49 is 0. So you tried 7, but 7 is also not working. Minus 7 is not working. Not working meaning both 7 and minus 7 do not satisfy the equation x squared plus 49 is equal to 0. In the equation x squared plus 49 is equal to 0, when you consider the LHS x squared plus 49, and when you use 7 or minus 7 in place of x, you get 98 in both the cases. You should get 0. That means it satisfies the equation. No, you're not getting 0. To get 0, you must get minus 49. X squared plus 49, if this should be 0, you must get minus 49 plus 49. Then only it will be 0. For what value of x and x squared will you get minus 49? Whether it is positive or negative, when you square it will become positive. No, then how will you get minus 49? X square will always be positive, but you want minus 49. Only then they'll get cancelled and 0 you will get. But there's no way you can get minus 40. X square cannot give you minus 49. Because whatever you put for x, when you square it, it becomes positive. So this is, of the many examples, this is one of the examples of a quadratic equation which has no root or no solution. No root or no solution. So basically you can write anything x square, take a plus sign and a perfect square. And a perfect square. So you can write 25, you can write 36, you can write like any perfect square, any perfect square. Simplest example, I'm not saying this is the only way, just for you to remember. Just for you to remember. If you take a minus sign, if you write x square minus 49 is equal to 0, this will have two roots. See here, so because x square is equal to 49, x is equal to plus or minus square root of 49, x is equal to plus or minus 7. So x square minus 49 is satisfied by both plus 7 and minus 7. So two roots. Plus 7 is one root, minus 7 is the other root. Both will satisfy the equation, because whether it is plus 7 or minus 7, you'll get 49 here. 49 minus 49, 0. So if it is x square minus 49 is equal to 0, then it has two roots. One root is plus 7, the other root is minus 7. Now consider this one. X square minus 6x plus 9 is equal to 0. Okay, this is a quadratic equation. Class, use the emoji. Raise your hand. Rajat, Raja, Danya, Raghavi, Shri Krishmi, Arjun, Ritika, Dilipan, Rakshita, Jayant, Tanishka, Florentina, Krishita, Sashank, Rahul. Who's the guest there? Sudha. Is that, who's that? Please introduce yourself. I can see someone with the name Sudha. Yeah, please let me know who it is. Rahul, are you there?
Yes, ma'am.
Okay. Is my screen and my voice, is my screen visible?
Yes, ma'am.
Okay. And my voice, is it reaching you clearly?
Yes, ma'am.
Okay, fine. Okay, Krishmi, I saw your message. Thank you so much, Krishmi. Okay. All right. Yeah, no problem. Krishmi, they can stay in the meeting. Yeah, thank you. Yeah. So we were talking about this example, x square minus 6x plus 9 is equal to 0. I didn't see Sri Ranjan. Sri Ranjan, are you there? Was he there in the meeting earlier, Sri Ranjan? Arjun?
Ma'am, I didn't notice, ma'am.
Okay, no problem. Okay. So we were talking about this example, x square minus, see, we saw, two examples, one like this, x square plus 49 is equal to 0, where the equation has no roots meaning no real roots. Okay, that is, there is no value for x which can satisfy the equation. And then when you take this one, here, this quadratic equation has two values, plus 7 and minus 7, which can satisfy the equation. Now look at this example. Look at this example. Okay, so here there's only one value. There is only one. Okay, let's take 3. Let x be equal to 3. Now see what happens where x is 3. 3 squared minus 6 into 3 plus 9 is equal to 0. Correct, children? Not as equal to 0. We are verifying, no? So we'll just LHS. Okay, the quadratic equation I've considered is x square minus 6x plus 9 is equal to 0. We're going to take x as 3. So 3 square minus 6 into 3 plus 9. What is the value? 9 minus 18 plus 9. 9 plus 9 is 18. 18 minus 18, 0. LHS is 0. RHS is also 0. Now, this equation is satisfied only when x is 3. For no other value of x, this equation will be satisfied. Now, how do I know that? I'll tell you how I know that. Now, factorize this. Factorize this. You can split the middle term, or you can use the form. You can use the identity a square minus 2ab plus b square. So when you factorize, you will get x minus 3 into x minus 3. When you factorize, you'll get x minus 3 into x minus 3. When you multiply x minus 3 and x minus 3, you will get this one. X squared minus 6x plus 9 is equal to 0. So x minus 3, when you equate it to 0, you get x is equal to 3. Here also x minus 3 is equal to 0, you get x is equal to 3. So you're getting the same value in both. So we say that the quadratic equation x squared minus 6x plus 9 is equal to 0 has two zeros. But they're the same. No, both the zeros are the same. That's why we say only 1 0. That is two identical zeros. It has two identical zeros. So you cannot take 3 and 3 as two different zeros. You cannot take it as two different zeros. So it has two identical zeros, which means only 1 0. Always when it is 1 0, it is two identical zeros. Always. Always when the quadratic polynomial or quadratic equation has, okay, if the quadratic equation has two roots or two solutions. Sorry, the phone call distracted me. I'm sorry. So always when the quadratic equation has 1 0, that means it has two equal zeros. 1 0 means two equal zeros. So either it has no zeros or it has two different zeros. Either it has no zeros or it has two different zeros. Or if it has only 1 0, that means there are two equal zeros. 1 0 always means two equal zeros. Am I clear, children? So no zeros, 1 0, 2 zeros. No zero means no zeros. 1 0 means two equal zeros. Both the zeros are 3. Both the zeros are minus 4. Both the zeros are 5. Two zeros means two different zeros. Like if this is something like 4, this is not 4, this is something else. Yes or no, children?
Yes.
All right. Finish writing this, all of you? Should I wait?
Completed.
Okay. Children, I just got a phone call. I need to attend that. 1 second, I'll just get back. Yeah, thank you, children. Yeah. So now we are going to learn the relationship between the zeros and the coefficients of a quadratic equation. Okay. Now we understood that ax squared. Am I audible, children? I'm back. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah. All right, children. Thank you. So we just understood that ax squared plus bx plus c is equal to 0 is the standard form of a quadratic equation in one variable x. Okay. And we also know that this can have a maximum of 2 zeros. A maximum of 2 zeros. So let's say the zeros are alpha and beta. These are Greek letters. Alpha and beta are Greek letters. Okay. So let's say that the 2 zeros are alpha and beta. Now, supposing I tell you that the zeros are, say alpha is -3 and beta is 5. Listen to this very carefully. Okay. Now, when you know the zeros, you can construct the quadratic equation. When you know the zeros, you can construct the quadratic equation. How? Okay. Now, if you want to construct the quadratic equation in y, because you can choose the variable x or y. Supposing you want to construct the quadratic equation in y, then see here, y minus alpha. Okay, let me take x because we're used to x. Okay, because first time I'm telling you, so let me not I don't want you to get confused. We're comfortable with x, no, because we use more of x. So x minus alpha into x minus beta is equal to 0. This product, because if -3 is a root, if -3 is a root, then that is if alpha is a root, x minus alpha is a factor. If beta is a root, x minus beta is a factor. What are we trying to understand now? If alpha and beta are the roots, with the help of the roots or with the help of the zeros, see the terms roots, zeros, solutions, they'll be used. Strictly talking, polynomial means zeros. Equation means roots, solutions. But these terms will be mixed and used. So you shouldn't take the strict meaning. I told you the difference, but it can be used interchangeably. So don't worry about that. So I'm saying when you know the roots, alpha and beta, then if alpha is a root, x minus alpha is a factor. And if beta is a root, x minus beta is a factor. And you know that the product of the factors can give you the quadratic expression. And when you equate it to 0, it's the quadratic equation. If I say that, like some number, its factors are 5 and 3 only. Some number, its prime factors are only 5 and 3. 1, 5 and 1, 3. So when you multiply, so that number is 15. When you multiply the factors, you will get the number. When you multiply the factors, you will get the number. See now, when you find like this, 50, 225 times 5 5s are 5 1s are. So that means 2 into 5 into 5. The product of the factors will give you the number 50. So if alpha and beta are the roots, then x minus alpha and x minus beta are the factors, and the product of the factors will give you the quadratic polynomial. You equate it to 0, it's the quadratic equation. So alpha is a root, beta is a root. X minus alpha is a factor, x minus beta is a factor. The product of the factors is the quadratic polynomial. When you equate it to 0, it's the quadratic equation. For example, if -4 and 3 are the roots or zeros or solutions, whatever you call them. Okay, if -4 and 3 are the roots or solutions or the zeros, then x minus alpha. So this is alpha. Alpha is -4, beta is 3. So x minus alpha. What is x minus alpha? X minus, this is alpha, into x minus beta. So that means that will be x plus 4 into x minus 3 is equal to 0. should take minus alpha means the negative of alpha minus beta, the negative of beta. See here, this is the x minus, this is alpha minus 4. X minus beta, beta is 3. So that means x plus 4 into x minus 3. So if alpha is minus 4 and beta is 3, just take them with the opposite signs. So you should write x instead of minus 4, put plus 4. And here it's plus 3, so take minus 3. This product will give you the, when you multiply this, you will get the quadratic polynomial. And if you equate it to 0, that's the quadratic equation. So what do you get when you multiply this? X into x minus 3 plus 4 into x minus 3 is equal to 0. So x squared minus 3x plus 4x minus 12 is equal to 0. So x squared plus x minus 12 is equal to 0 is the required quadratic equation whose roots are minus 4 and plus 3. X squared plus x minus 12 is equal to 0 is a quadratic equation whose roots are minus 4 and plus 3, which means when you know the zeros, when you know the two zeros or when you know the two roots or the two solutions, you can find the factors. Using the roots, you can find the factors. And by multiplying the factors, you will get the quadratic polynomial. And when you equate that to 0, you get the quadratic equation. Very easy. Very easy. So alpha and beta are the zeros. Now these are the zeros. Okay. And now we need to understand the meaning of the terms coefficients. Okay. So in ax squared plus bx plus c is equal to 0. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Alpha and beta are the zeros. Alpha and beta are the zeros. The coefficients are A is the coefficient of x squared, B is the coefficient of x, and C is the constant. Now we are going to understand the relationship between the zeros and the coefficients, the zeros and the coefficients of a quadratic polynomial, Okay, so I told you what zeros are. Zeros are alpha and beta. And what are the coefficients? A, B, and C. The coefficient of x squared is A, the coefficient of x is B, and C is the constant. That is also regarded as a coefficient. Why? Because it's like this: ax squared plus bx plus c x to the power 0. This is x to the power 1. So C is also regarded as a coefficient. Because anything to the power 0 is 1. Anything to the power 0 is 1. So C can be written as C x to the power 0. C can be written as C x to the power 0. So C is also regarded as a coefficient. That's the coefficient of x to the power 0. Okay, the coefficient of x to the power 0 is C. The coefficient of x to the power 1 is B. And the coefficient of x squared is A. So we're going to now understand the relationship between the zeros and the coefficients of a quadratic polynomial. I'll just put it in a very simple way for you. In the next class, I'll check if you have that real proof. The real proof is different. Okay, so last year it was not there. So I'm not doing it now. But I just want to tell you how we find it in a very different way, in a simple way, in a simpler way. If you have the real proof, I'll check with you. If you have the real proof, I'll do it in the next class. Okay, so now ax squared plus bx plus c is equal to 0 on one side. Alpha and beta on the other side. That is, how will you get it? X minus alpha into x minus beta is equal to 0. Okay, I'm having it on both the sides. Both are the same, children. Ax squared plus bx plus c is equal to 0 is the quadratic equation. How will you get that quadratic equation? By multiplying the factors x minus alpha into x minus beta. When you multiply the factors, you get the quadratic equation. Yes or no, children?
Yes, ma'am.
On one side, I've written the quadratic equation. On the other side, I have written how to get the quadratic equation by multiplying its factors, x minus alpha into x minus beta. Y is equal to 0 because quadratic equation. Now here what we do is we divide by a throughout. So what do you get? Ax squared by a plus bx by a plus c by a is equal to 0 by a. So you get x squared plus b by a of x plus c by a is equal to 0. Yes or no, children? Please watch that. Yes or no, children? Understood that?
Yes, ma'am.
On this
Yes,
side. Now
ma'am.
let's work this side also. Very good. Let's work this side also. So x into x minus beta minus alpha into x minus beta is equal to 0. So you get x squared minus beta x minus alpha x plus alpha beta is equal to 0. So x squared, I'm just rearranging, minus alpha x, like we say A, B, C, D. So like that, alpha, beta, gamma. Normally that order. Somebody's mic is enabled. Disable your mic. Children, there's somebody at the door. I'm just coming. Just a minute. Yeah. Yeah, children. So like we say A, B, C, D, like that alpha, beta, gamma, that order. So minus alpha x minus beta x plus alpha beta is equal to 0. Now, on this side, if you see, there is one x square term, there is one x term, and one constant. There are only three terms on this side. One x square term, one x term, one constant is equal to 0. But on the other side, you have four terms. You have one x square term, two x terms and one constant. So you need to make the two x terms only one x term. Okay, for that we need to take up x common. Take out x common. Okay, so what do you get? Now tell me what do you get in the bracket? What do you get in the bracket?
Alpha plus beta.
Alpha plus beta. Plus alpha beta is equal to...
No, plus beta.
Yeah, I've taken a minus here. So it will be minus alpha into x minus alpha x minus into plus minus beta x.
Yes.
Yeah. So since on the left side, we have only three terms, x square, x and constant. On the right side, we have four terms, one x square term, two x terms and constant. We had to take out that x common and make it one x term. So now there is only one x term minus alpha plus beta of x. Only one x term is there, is equal to 0. Now it's, the two sides are ready to be compared. Why now they're ready to be compared? Because now they look alike. Three terms on this side, three terms on this side. X square, x constant, x square, x constant. Now you can compare. Now, when you compare both the sides, when you compare the coefficients of x, what do you get here? What's the coefficient of x here? B by a. What's the coefficient of x here? Minus alpha plus beta. Minus of alpha plus beta. Yes or no, children?
Yes.
When you compare, on comparing both the sides, let me write that on the next slide. 1 minute. Okay. See here, this one. Okay, I'm comparing this. See, there's nothing to compare with x square and x square. X square equal. So nothing, what can you compare there? Okay, so there's nothing there. So we did not do anything with it. The next one, that is the x terms we are comparing. And then we'll compare this one, the constant. Then we'll compare this one with this one, with this one. The constant with the constant. So I'm writing that on the next slide, children. I'm writing it here. So on comparing, we get, what do you get on comparing? We get, what do you get? Minus alpha plus beta. That is, we are comparing minus alpha plus beta of x with b by ax. Sorry. Okay, we are comparing this with b by ax, b by ax. So what happens? X and x on either side gets cancelled. So we have alpha plus beta is equal to this. We're changing the signs on both the sides. I hope you understand this. So alpha plus beta is equal to minus b by a, or the sum of the zeros. Sum of the zeros is equal to minus, what is b? The coefficient of x by the coefficient of x squared. Coefficient of x squared. This is the relationship between the zeros and the coefficients. Now let's compare the constant c by a with alpha beta. So again, on comparing the same thing, okay, on comparing both the sides. Okay, let me write here. Okay, so this is one thing when you compare. Okay, the other thing again, when you compare both the sides, you get, see your children, alpha beta is equal to c by a. On the side you have alpha beta, the side you have c by a. So alpha beta is equal to c by a. What does this mean? That means the product of the zeros. Alpha beta is the product of the zeros. So product of the zeros is equal to the constant term. C is the constant term. Constant term divided by the coefficient of x squared. So alpha plus beta. Alpha and beta are the zeros. A, B, C are the coefficients. See, that's what you need to be very, very clear about. Okay, let me write it here. Okay, I'll just write it here. A, B, C are the coefficients. Alpha and beta are the zeros. Alpha and beta are the zeros. A, B, C coefficients. We are trying to understand the relationship between the zeros and the coefficients of a quadratic polynomial. So this slide you have understood. When you compare both the sides, you find alpha plus beta is equal to minus b by a. That is the sum of the zeros. Alpha plus beta meaning the sum of the zeros is equal to minus, whose b? The coefficient of x, by a. Whose a? The coefficient of x squared. Alpha beta is equal to c by a, meaning the product of the zeros is equal to c is the constant term divided by a, which is the coefficient of x squared. This is the relationship between the zeros and the coefficients. Is this understood, children?
Yes, ma'am.
Yeah. Now, this is the derivation. Children? Am I audible?
Yes, ma'am.
No.
Yes.
By mistake, no. By mistake, the internet switch was switched off by somebody at home. There are some guests at home, so it's near the television switch, and somebody put it off by mistake. So I was not in the meeting for some time. Yes or no? For about 2-3 minutes, yeah, there was no connection. So don't worry. I was not in the meeting at that time, so there was some. Yeah, my meeting was put on hold because of that. Are we all there now? Am I audible? I think I have to share my screen again.
Yes, ma'am.
Yeah. I'm doing that. Yes, children. Yeah, quickly make a note of this, children. All of you must write. Please write. Done this one, children? Children, finish writing this. Let me know.
Completed, ma'am.
Okay. Anybody still writing? I'll wait. Okay, so all of you finished. Fine. Yes, I think it's should be done by now. Okay. All right, assuming it's done. Please stop me if you have not done. Done, children?
Yes.
All right. Now look at this one. Factorize and verify the relationship between the zeros and the coefficients. You need to first factorize this. Okay, again, factorization you've learned last year. So you need to factorize this and then verify the relationship between the zeros and the coefficients. Okay, so let's do this together. Can I ask one of the new students, Rahul? Can you help me factorize this, Rahul? Are you there, Rahul? Okay, Krishita, do you want to try, Krishita? All right, no response. Who wants to try this? How do we factorize this one?
Splitting the middle term, ma'am.
Splitting the middle term. Fine. What's the sum?
2√3.
Very good. What's the product?
Minus 24.
Don't write anything now, children. Do not write anything now. I have the answer slide. I'll show it to you. Don't write anything now. Okay. Now, what are the two numbers that satisfy the sum and the product? Work that and tell me. The two numbers that satisfy the sum and the product.
Ma'am, +2√3 and -4√3.
Plus 2√3 and minus 4√3. You're right, but the signs, are you sure about the signs? Or you want to change them?
I'm sorry, ma'am. -2√3 plus 4√3, ma'am.
Very good. Minus 2√3 and plus 4√3. Because when you find the sum of these two numbers, you get 2√3 and their product. 4 2s are 8. √3 into √3 is 3. And so 8 3s are 24. Minus into plus is minus 24. Very good, Raja. So x squared, the two numbers or the required numbers to split the middle term. The required numbers to split the middle term are 4√3 plus 4√3 and minus 2√3. So write x squared, then plus 4√3x minus 2√3x minus 24. Now you'll have to group. Okay, the rest of it will follow. So now then you'll have to group and then equate it to 0 to find the zeros and then verify the relationship between the zeros and the coefficients. Fine. Now see the answer slide. Now, some of you have a doubt as to how to find this 4√2, 4√3 and 2√3. I'll explain that now. See here. I'll explain that now. You all said that the sum is 2√3 and the product is minus 24. Now take up the product. Take up the product. For those who find it difficult to find the two numbers, please listen to this carefully. Take up the product 24. So 2 12 times. 2 6 times, 2 3s are 3 1s are. So 24 is equal to 2 into 2 into 2 into 3. Write that. Take up the product. Write 24 is equal to 2 into 2 into 2 into 3. That's the first step. Now, since the sum has √3 in it, there is √3 here. Write that √3 as, sorry. There's a 3 here. Write the 3 as √3 into √3. Write the 3 as √3 into √3. See, the sum is 2 √3. So here you have root 3, no? So sorry. Here there's a 3, right? Write that as root 3 into root 3 because root 3 into root 3 is 3. So that's the next step. Write 3 as root 3 into root 3. That's the next step. After writing 24 as a product of its factors, next step is write 2, 2, 2 as it is. 3 is root 3 into root 3. That's the next step. Now you will have to make two numbers, but you know that both the numbers should have a root 3 in them. Then only you will get the sum as 2 root 3. So see here, I just put two brackets. I've just put two brackets. This number also should have root 3. The other number also should have root 3. So root 3 is gone. So the remaining numbers are 2, 2 and 2. So like 2 2s are 4 and 1 2. So 4 root 3 and 2 root 3. Like this you should make combinations. It's not easy always. You have to try like this. I gave you some idea. Now you should work on that. I told you because it's 2 root 3, you should split 3 as root 3 and root 3. So one number will have root 3, the other number also will have root 3. So now we have 2, 2 and 2. So I've taken 2 2s here and 1 2 here. So I get 4 root 3 and 2 root 3. Now fix the signs. Fix the signs because you want to get plus 2 root 3 and minus 24. So fix the signs. Then you can see here, I split the middle term. Just a second, children, just a second. Yeah, children. Where did I stop? Yes. So I said then you'll have to split the middle term. So you can see here splitting the middle term. You can see here. You should know this. You should know this. Otherwise, you ask me. This is of 9th standard. You must know it. If you don't know, you have to ask me. Okay. So that means x square we have now factorized. So the given quadratic polynomial x square plus 2 root 3x minus 24 is equal to this into this. On factorizing, you get these are the two factors. These are the two factors of this quadratic polynomial. See, actually now we don't know what are we doing? Why are we doing all this? I'll tell you all that clearly. I'll tell you all that. So first factorize and get the two factors. After that, equate each factor to 0. X plus 4 root 3 and x minus 2 root 3. Equate them to 0. Equate them to 0. So you get x is equal to minus 4 root 3 and x is equal to 2 root 3 here. Okay, so you get the two values of x. So now one of the values of x is alpha, the other one is beta. Because the two values of x, they are the two zeros. They are the two zeros. So alpha, anything, see, you can take this as alpha and this as beta. That's okay. Any one is alpha, the other one is beta. So how do you find alpha and beta? You must take up the quadratic polynomial, factorize it by splitting the middle term or any method. You'll have to factorize it. And then you will get two factors. Equate the factors to 0 and find the zeros. So the two zeros are minus 4 root 3 and 2 root 3, which means alpha is minus 4 root 3 and beta is 2 root 3. So now you found the zeros. Now you should find the coefficients. Write the coefficients. How do you write the coefficients? You just have to compare the given quadratic polynomial with ax squared plus bx plus c. See, what's the question? Verify the relationship between the zeros and the coefficients. So you should have the zeros with you. You must have the coefficients with you. Only then you can verify the relationship between the zeros and the coefficients. The coefficients you already have because this is the quadratic polynomial. So the coefficients are 1, 2 root 3 and minus 24. The coefficients we already have because when you compare the given quadratic polynomial with ax squared plus bx plus c, then you have the values of a, b, c. A is 1, b is 2 root 3 and c is minus 24. So coefficients we already have. Zeros. How to get the zeros? For that you have to factorize. And on factorizing you get the two zeros. So the two zeros are, sorry. are this and this. So to get the zeros, you have to factorize. To get the coefficients, you'll have to compare the given quadratic polynomial with the standard form ax squared plus bx plus c. Simple. ABC can be got by comparing with the standard form ax squared plus bx plus c. Zeros, alpha and beta, you will get by factorizing. Now you're ready to do the verification. With the values of A, B, and C and alpha and beta, you're ready to do the verification. What's the verification? You should find alpha plus beta. What is alpha plus beta? Find that. You get this one. Next, find minus B by A. What is minus B by A? This one. Minus B by A. This one. Minus B by A. You get minus 2 root 3. So you see here that alpha plus beta, the value of alpha plus beta is the same as the value of minus B by A. So you're verified. You're verified that alpha plus beta is equal to minus B by A. You're verified that. Next, verify alpha, beta, and C by A. So find alpha, beta separately. What is alpha, beta? Alpha into beta, multiply these two. Multiply these two. So alpha, beta is minus 24. Next, find C by A. What is C by A? Minus 24 by 1. C by A, minus 24 by 1, which is minus 24. So you see that alpha, beta is minus 24. C by A is also minus 24. So you verified that alpha, beta is equal to C by A. This is the verification. So the question is factorize. See, so you factorize. Till here is factorization. You factorized. And then you should verify the relationship between the zeros and the coefficients. So here we have done the verification. Is it understood, children?
Yes.
All of you? Okay, so it's time. I just want to do 2 more sums. So I'll share this image on WhatsApp with you. Soon after the class, I'll share it. Soon after the class, I'll share it. You can complete this in your classwork. Now see the next one. Yeah, you can take this as a homework. Take this as homework, children. I'll send this as homework, okay? Yeah, this is the next one. This is the next one. So here I'll just tell you how to factorize. I'll tell you how to factorize, that's all. So y square, please hold 5 minutes. I'll, finish the meeting. So y square minus 24. How to factorize this one? Here you're going to split the middle term here. So y square minus 24 meaning you can do it like this. Y the whole square minus root 24 the whole square. Root 24 the whole square. So this is in the form a square minus b square. So a plus b into a minus b. A plus b into a minus b. A minus b. Okay, so you'll get y plus, root 24 can be written as, this is 8 3s, no, 4 6 are 24. 4 6 are 24, so it's 2 root 6 into y minus 2 root 6. So when you equate this to 0, you will get y is equal to minus 2 root 6 and y is equal to plus 2 root 6. So this is the alpha, this is beta. Alpha, beta you got. So how did we factorize here? By using the identity a square minus b square. A plus b into a minus b. Here we have to factorize by using the identity a square minus b square, which is a plus b into a minus b. You should write 24 as root 24 the whole square. You must write 24 as root 24 the whole square because it's not a perfect square. See, if it was y square minus 16, then you can write y square minus 4 square because 16 is 4 square, but 24 is not a perfect square. So you write it as root 24 the whole square. So then you factorize using the identity a square minus b square is equal to a plus b into a minus b, and you get the two factors. On equating to 0, you get the two zeros. Now the coefficients. Next, the coefficients. Okay, so y square plus 0y minus 24. So when you compare this with the variable is y, so I'll write it as a y square plus by plus c. A y square because the variable is y. So what is a? 1. What is b? 0. And what is c? Minus 24. That's all. Now you have the zeros, you have the coefficients. Verify the relationship between the zeros and the coefficients. So it's here, children. I'll share the slide. I'll share this with you. And here is a case where you have to factorize in a different way. This is in a different way, factorization. 8d square minus 12d. Here, how do you factorize? You should take out the common factor. 4d is common. 4d is common. So you will get 2d minus 3. Correct? 8d square minus 12d. Write it again. 8d square minus 12d. That is, you have only the d square term and the d term. You don't have the constant. Here you have the, here you don't have the middle term. The y term you don't have. Here you have y square. See here, two things only can go missing, children. The square term should be there. That is the y square or x square should be there. So what can be missing? That the middle term, that x or the y term, and the constant. Here who is missing? The middle term. That y term is missing here. The y term is missing here. Then how do you factorize? By splitting the by using the formula a square minus b square. Whenever that middle term is missing, that y term or the x term is missing, we always factorize by using the formula a square minus b square, a plus b into a minus b. When the last term, the constant is missing. So see here 8d square minus 12d, that constant, that number alone, d square is there, d is there. That constant is missing. Whenever the constant is missing, how do we factorize? We take out the common factor. So 4d is common. 4d is common. 2d minus 3. So equate. These are the two factors. This is one factor. This is the other factor. So 4d is equal to 0. D is equal to 0 by 4. D is equal to 0. And the other 0 is 2d minus 3 is equal to 0. 2d is equal to 3. D is equal to 3 by 2. So alpha is equal to 0 and beta is equal to 3 by 2. And when you compare this with a d square, because the variable is d, a d square plus b d plus c is equal to 0. Okay, or just plus c. When you compare a d square, so a is 8. A is 8. Okay, then b d is minus 12d. So b is minus 12. And c is not there. So c is 0. So you have the coefficients a, b, c. You have the zeros. Now you can verify this relationship between the zeros and the coefficients. So what you should understand is 8d square minus 12d. The constant is missing. When the constant is missing, how do you factorize? By taking out the common factor. By taking out the common factor. And when the middle term is missing, how do we factorize? By using the identity a square minus b square, a plus b into a minus b. When all the three terms are there, we factorize by splitting the middle term. So for each one, we have a different way of factorizing. When all the three terms are there, factorize by splitting the middle term. When the middle term is not there, you should use a square minus b square, a plus b into a minus b. And when the constant is not there, we take out the common factor. The common factor. 4d is the common factor. We take out the common factor. So like this, you factorize and then you verify the relationship between the zeros and the coefficients. You must have the zeros alpha and beta, and you must have the coefficients a, b, and c in order to verify the relationship between the zeros and the coefficients. I'm sharing all these slides right away, children. Yeah, from here we'll continue in the next class. I'm sharing all these slides right away. Please complete this. Finish your dinner and complete the classwork. Otherwise, you'll forget. Till here you have written. The notes you have written. From here, 3 sums you'll have to, 3 and 1 sum is homework. 4 sums you'll have to complete. Are we all there? Only 14 students now at the end of the meeting. Okay. Who's there? Arjun, Danya, Florentina, Krishita, Rajit, Rahul, Raja, Raghavi, Rakshita, Dilipan, Ranjan, Krishmi, Tanishka. Okay. Wait, I don't see Ritika. All right, children. I hope the introduction and the few sums which I did on, polynomials is clear today. please go through all this before you join the next class on Saturday. And as I texted you all, the air conditioning work is in progress in the center, meaning I've just asked for the quotation and, they're just coming to the center to take the measurements and all that. So it'll take some time. Mostly next week, from next week, we'll resume the physical classes. But please cooperate till the work is done. Now don't start, like thinking that is it going to be online always? No, there is some work there to be done. I told you the air conditioning work is to be done in the center. That will take a maximum of 1 week. So by next week, mostly by next Thursday or at the most by Saturday, we'll resume the physical classes. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am.
Good night, children.